All right, here we go. So this second part here is going to be writing various angles here in terms of some of the angles from our chart back up above that you've already filled in at this point. Now the reason we're doing it is going to be in the next box. You'll notice your sine and cosine sum and difference formulas, and we'll need to know how to get these angles such as 15 degrees that we don't have that one memorized. Well, hopefully 15 degrees actually we do it as pi over 12. But being able to build it out as a sum and difference, sum and or difference of two different angles that we are more familiar with. So for example, here we go, 15 degrees. Now, of the angles we already know, how would we get 15? Well, looking at the chart, we know 45 and we know 30, so we can do 45 minus 30, and that'll get us there. I mean, you could also, I suppose, do 135 minus 120, but I'd go with whatever is the smallest option, most straightforward way to go. And so we'll do that 15 degrees is 45 degrees minus 30. And again, I do want to point out that it is the same thing also as 60 degrees minus 45, as 135 degrees minus 120. I suppose you could even go all the way up to 300, 315 minus 330, or 300 minus 315, so on and so forth. But there gives you a good start of those. So 105 degrees, writing it as, this one's a little bit bigger, so you can write it in terms of a sum as well. For example, it could be 60 degrees plus 45 degrees. And then as a difference, let's see, 100 and let's go 135 minus 30. 135 degrees minus 30 degrees would get us 105 degrees. So, yeah, I'll let you figure out, or we'll go ahead and do it. Negative 75, let's do negative 30 degrees minus 45 degrees. And though I'm not exhausting it, there's other options that we, different ways you could write that. So 60 degrees minus 135 degrees. And again, these are not the only options. There are multiple options you have. So here's just a few examples. Now in radians, same idea going on. It's going to be a good idea to think in terms of, for radians in particular, in terms of those twelfths. And degrees, we're already familiar with the 30, 45, 60, and those are easy units to add and subtract in. The radians that we're used to are in fractions that don't go together without a little bit of conversion. And again, that's why we did that full chart up here. So if we are trying to get 5 pi over 12, well, hey, I know that 1/6, that'd be 2 pi over 12, plus 1/4, which would be 3 pi over 12. There's my 3 pi, and there's my, there's my 2 pi, there's my 3 pi, and so 2 pi plus 3 pi gives me that 5 pi and the 12ths over 12. So you could, again, that, just to be explicit about it, that is pi over 6, which we're familiar with that one, plus pi over 4, which we're familiar with that one as well. That's a 30 degree plus a 45 degree. And let's finish up this box here. So here we want to get 11 twelfths. Well, what are some of the twelfths we know? We've got, let's see, a 3 here and a 8 there. We could add those together, or the 2 and the 9. That would also get us to 11. And so those are some of the ones we know. Let's do 3 twelfths pi plus 8 twelfths pi, which in terms of the ones that we're familiar with, this is pi over 4 plus 2 pi over 3. So you do know these measures already. If we're doing sine or cosine, you could give the value for those. Last one, let's go, if we're trying to get to 19, let's go with 10 pi over 12 plus 9 pi over 12, which is going to be the equivalent of 5 pi over 6 plus 3 pi over 4. All right. And now, it's probably been a little bit confusing as well. Sure, we can do that, but why? And we'll start to make that a little clearer in the next few videos. All right.